This is objective 6.2. The student will be able to define and use the natural base E, graph natural base functions, and then solve real-life problems involving the natural base. So the big concept here that we're going to work with is the natural base, which is written as E. So E, the natural base, is an irrational number like pi, and is defined as x approaches positive infinity, so as x gets bigger and bigger, 1 plus 1 over x to the x power approaches this value of E, which is 2.71828182846, and so on. So this should continue on out. This doesn't end, it's irrational. So, a lot of this, the first part's going to be fairly easy for you. Okay? E is just like any variable. So e to the third times e to the sixth. Remember, if you have the same base, you add the exponents, and so this would be e to the ninth. If it's division, just divide the number. 16 divided by 4 is 4. Remember, when you divide, if it's the same base, you subtract powers, and so that would be 4e. And then here, the square, remember, affects all of it. So you square the 3 and it becomes 9. And then a power to a power you multiply, and so that would be e to the negative 8x. Okay? I don't think the book will have you do this, but remember you could also do this e over 8 to the x power, because the negative sends it opposite where it's located. So I'm not sure how the textbook will do that, if they'll let you leave it this way or if they'll have you switch it to that. So right now I'd like you to pause the video and go ahead and try these 3 problems and come back and check and see how you did. So again, same base, add exponents. 24 divided by 8 is 3, subtract exponents, e to the third. And then 10 to the third power is 1,000. And then a power to a power you multiply, so that'd be e to the negative 9x. So hopefully those are, if we've understood what we've done up to this point, that part should be fairly easy for you. Now, natural base functions. So a function in the form of y equals ae to the rx, okay, that's an r times x, is called a natural base exponential function. If a is greater than 0 and r is greater than 0, then the function represents growth. If a is greater than 0 and r is less than 0, so negative, then the function represents decay. So if we were to look at these problems, so again we're looking at the r value, so in this case our r value would be 1, which is greater than 0, so this would be a growth. And e to the negative 0.5x, since our r is negative 0.5, that would be a decay problem. And again, I won't have you graph these, but if it asks you to graph, I will expect you to make charts. So if we were to go to the graphing calculator, so the first one was y equals 3e to the x, y equals 3, then just go to the alphabet and it will take care of it for you. E to the x power, and it gives you the graph. So again, you can get the table, just go here, table, and you got the values from -2 to 2. That's enough information. You don't need to, again, draw the graphs, but you'd have the values there. So if you were to graph again, you would just plot those points and connect it. Okay? Enough to get an idea of what the graph looks like. And then the second one is e to the negative 0.5x. So y equals e was negative 0.5x. And so again, we get the graph, and again, you don't need to show that, but if you had the table, you would get the table and just write that down for your answer. Then again, it's not hard. I'm again assuming you can plot the points and connect them to get your graph. So What I'd like you to do on this is determine whether it's growth or decay, and then simply make the charts. So you, just again, so we make sure we know how to do this. So go ahead and pause the video, try those three, and then come back and check and see how you did. So the first one, our R value is 1. So this would be a growth. On the second one, our R value is -1, so that is decay. And our last one, our R value is 2, and so that is growth. And if you were to have graphed those, y equals 1/2 e to the x, y equals, I'm going to have to put that in parentheses. I don't know. Actually, I don't need the parentheses on that thing. 1/2 e to the x. Oops. Okay, so you should have gotten the table. -2 is, again, to the nearest hundredth, 0.07, -1, 0.18, 0, 0.5, 1, 1.36, and 2, 3.69. So that gives you your table. The second one was y equals 4e to the -x. Y equals 4e to the -x. And so we get this. Again, your table. At -2, you should have been at 29.56. -1, 10.87. 0, 4. 1, 1.47. And 2.54. So again, you have that negative exponential growth chart. And then the last one, 2e to the 2x. Y equals 2e to the 2x. So again, we go get our table, and you should have had at -2, you were at 0.04, -1, 0.2702, 1 at 14.78, and 2 at 109.2. So again, pretty easy to do. Plug it in to the calculator, get the chart. Again, you just have to determine if it's growth or decay. Then, the last part, core concept, continuously compounded interest. When interest is compounded continuously, the amount A in an account after t years is given by the formula P equals E R to the t. So it's just continually compounded. Where P is the principal and R is the annual interest rate expressed as a decimal. So we're going to go ahead to the textbook because there's a lot of writing on this and look at page 306, number 3. So number 3, it says, you and your friend each have accounts that earn annual interest compounded continuously. The balance A in dollars of your account after t years can be modeled by the formula 4,500E times 0.04T, so you're at 4% interest. The graph shows the balance of your friend's account over time. Which account has the greatest principal? Well, your principal is 4,500. Your friends, you can tell by the chart because when t is 0, that would be your initial amount. And remember, any interest times 0 is 0, and anything to the 0 power is 1. So we know by your chart that 4,500 is what you started with. We know by the graph, at 0 we're at 4,000, so we know that your friend started with 4,000 in their account. So they started with 4,000. So you can simply find that on the graph by at what value you're at 0. Then it says, which has the greater balance after 10 years? Well, To calculate yours, we can simply go to the graphing calculator. 4,500, so we're going to go at 4%. 4,500 E, and it was 0.04, and we want to know in 10 years, so times 10. And we can see that you're going to have $6,713.21 in your account. 6,713.21. So you're going to have $6,713.21 in your account after 10 years. Well, if we go to 10 on this graph, we can tell that your friends, since this is 6,000, 7,000, they're at about 7,000. The book estimates 7,250. But you can see that it's over 7,000. So you can see that your friends, since they're over 7,000, got more money in their account than you do, even though they started with $500 less. So what do we know about the interest rate? The interest rate has to be higher. And so we can tell that by the graph, even though we don't know their interest rate exactly, and we could calculate that. But we do know that your friend is getting a higher interest rate than you are. So then they wanted us to look at, so this one says you deposit $4,250 in an account that earns 5% annual interest compounded continuously. Compare the balance after 10 years with the accounts in example 3. So now they want to know if we compare this amount where you had 4,500 and you had 6,713.21, and your friend's account who had, we're saying, 7,250 in their account, then we want to compare and see what's going to happen if you deposit 4,250 and you get 5% interest for 10 years. Right? 10 years. So, if we go to the calculator, so we're going to go 4,250, but we're going to do 5%, so 0.05, and we can see that we're going to have $7,700 or $7,007.07. So we're going to have in this account $7,007 and is it 7 cents? Back there, yeah, 0.07. Okay? So we can see now that it's somewhere in between. Okay? Because at 4,000, we entered an approximation in between, but we still have less money than the other person. We really can't compare exactly unless we calculate their interest rate, what their interest was. But that's what you're going to be doing on this assignment. So the assignment is page 307, numbers 3 to 35 of the odds. Again, you don't have to do this until you get to class, and we'll have the parade work on it. Unless you're absent, then you need to do